In this video, we're going to go over categorizing scatter plots and then fitting non-linear models to data. So in our first example here, we have to decide whether each set of data could best be modeled by a linear model, which is y equals ax plus b, an exponential model of y equals a times b raised to the x, or a logarithmic model of y equals a plus b times the natural log of x. So if we look at our first set of ordered pairs for part A, and then we look at B, look at C, it's something kind of interesting, which will make our job a little bit easier. So if we take a look at just the points for X, those points are the exact same ones for part B and for our set C data points, which is awesome. So what does that mean? Well, that means that for us, we can use for A, list 1 and list 2, but for list B, we can reuse list 1 and not have to enter that again and put list B into list 3. And then we're going to go ahead and keep list 1 for also C, but we'll use list 4 for the Y values of part C. Now, the reason why we're not going to be deleting things is our next example also uses these data points. So what you need to do now is you need to pull up your calculator and go to Stat and go to Edit and enter in your data points. So I'm going to go ahead and have you push pause and to put your data points, the X's into your L1, and then A's, Y's into L2, and B's Y's into L3, and C's Y's into L4. Then when you're done, push play, and we'll go from there. Once you have all of your lists filled out, we're ready to look at our scatter plot. So we're going to go to our window, and we're going to change our window to go from 0 to 10 for our X minimum to our X maximum with a scale of 1s, and our Y minimums to go from 0 to 12 with a scale of 1. And I determined these numbers based off of the values in my data set. Once I have that, I'm able to go to my stat plot, and we're going to turn on our first stat plot. So I'm going to turn it on, and it says, what's your X list and what is your Y list? Well, on this first one, list 1 is perfect because that's what all of my X's are. And for my Y's in part A, it was from list 2. So I have list 1 and list 2, which exactly is what we have written up here. So I'm going to go ahead now and hit graph, and I'm going to look at that and go, gosh, what kind of a trend does that have? It doesn't really look like a straight line, but it's going from kind of like low to high. So as X is increasing, Y is increasing, and that's more exponential than logarithmic. And so that answer is going to be an exponential model would be our best fitting model. So now we can go back to our calculator, and we're ready for part B. So we want to turn off our stat plot for part A, so we'll turn that off. Then, kind of a shortcut is I can just arrow over to plot 2. So I'm going to arrow over to plot 2. And here on plot 2, I need to turn it on. And then my X list is list 1, but my Y list should say L3. It needs to be L3 because remember, we made our Y values the L3 list for this part. So the L3 is above the number 3, but it's written in blue. So you'll have to touch it with the blue button first. You'll have to hit second, 3, to get the L3 to pop up. Once you've done that, hit graph. Now as we see this, it kind of looks like it could be a straight line, but there's definitely kind of like a bend in it. So this looks a little bit more logarithmic. So a logarithmic model would be the best model for this set of data points. And now we'll check our third set. So we'll come up to our stat plot, and go to stat plot 2, and we'll turn it off. Then we'll arrow up and go over to plot 3. And we'll turn it on. And now here we said X was list 1 and Y was list 4. So we want to make sure our X list says L1, but that our Y list says L4. And L4, list 4, is above the number 4. We'll just have to hit second first. So second, 4 gives you L4. Then we can hit graph. See, this one looks a lot straighter than that last one did. So this would be a good linear model. Now, our next example says to fit the data set from example 1A to an exponential and then to a power model. It asks us to identify the coefficient of determination and to determine which model fits the data better. So we're going to pull up our calculators, and we're going to go ahead and we'll turn our stat plot off. And we're going to go to Stat, Calculate, and we're going to calculate our exponential regression. So we're going to arrow down so we see EXP-reg. So option 0 says EXP-reg. So we're going to hit enter and have our list 1 and our list 2. We're going to ask it to calculate. So we'll go down to calculate. And here I see my A, my B, my R squared, and my R. So what happens if your R squared and your R don't show up? Well, that means you need to turn on your statistic diagnosis. So go ahead and write these down, and let's write our model down, and then I'll show you how to turn your stats diagnosis on. So for our exponential model, we have y equals 0.507 times 1.368 raised to the x power with an r squared value of 0.9945. So the r squared is our coefficient of determination. So how do we turn it on? Go to Mode, then arrow down to Stats, Diagnostics, and make sure that you go and hover on top of On and hit Enter to turn it on, and then you can quit to get out of it. So now we're going to finish by doing our power model. So to do our power model, we're going to go to Stat, Calculate, and we're going to arrow down until we get to Power Reg, which is option A, PWR Reg. We'll hit Enter. We're using list 1 and list 2 because it was from part A. We're going to go down and tell it to calculate. And here we have our A, B, R squared, and our R. So we're going to go ahead and write those down in the model. And so here for our power model, we have y equals 0.249 times x raised to the 1.518. And our coefficient of determination, or our r squared, is 0.9315. Now to determine which model fits the data better, we're going to compare the coefficients of determination for each model. So we're going to be looking at our r squareds. So the model whose r squared value is closest to 1 is the model that better fits the data. So in this case, the better fitting model is the exponential model, as our r squared value is closer to the number 1.